And before that, I would like to share some information about the company visit and the drop-off service that is provided by the host association. So please take a seat so that we can start in about 1 minute, please. Okay, we are about to get started. Before we start with the next session, the ITMF Startup Award session, a little information about the company visits. So we will leave at 2:30, the buses will leave at 2:30. We are going to visit 2 apparel companies first. So the group has to divide in 2 groups. One group goes to that apparel company and the other one to the other one. And then after these visits, everybody will go to join another visit of a cluster company, which is another word for an integrated textile company that does everything from cotton growing up down to the finished product, in this case apparel production and carpets. So that's the procedure. We will first visit 2 apparel companies, divide in 2 groups. One group goes to this company A and the other one to this company B. And then everybody will meet at the 3rd company C for a joint visit of this integrated company. So 2:30, we will leave in front of the Congress Center. Information about the drop-off. For those who have not yet arranged a drop-off or want to reconfirm with the host association, they have in 2 hotels, in the Hilton Hotel and in the Minion Hotel, support desk, help desk, where you can contact them and arrange your drop-off at the airport or at the train station. Again, in the 2 hotels, the Hilton and the Minion. Please contact the staff that is probably sitting there at the desk or at the roll-up, the conference roll-ups, and or contact them here at the Congress Center for support if you are still unsure about how to get to the airport and to the train station. With that, I hand over to Professor Kang to moderate the session Startup Awards 2024. Thank you.
Good morning, ladies and gentlemen. I'm going to start second session of this morning. This session is for the 4 winners of the ITMF Startup Awards. I am Tai Kang from Seoul, and I am the member of ITMF board. This year, we have 17 applications for Startup Award. It was unfortunate that we could choose only 4 winners among these 17 startups of, very bright ideas with perspectives for the future. Startups are vital for the economic growth and creating jobs due to their crucial role in fostering innovation and technology advancement. Startups are a significant source of job creation. This job creation helps reduce unemployment and contributes to overall economic stability of the nation. Startups often introduce new technologies, new products, new ideas, as you are about to listen from the 4 winning startups of the awarded by ITMF this year. Let me start 4 winning startups from left. Byron, melt spun fibers without oil or waste by Oliver Shepard. Next is a Psychotex light film of topological soft gel for thermal insulation by Sinning Mao. The third one is LEAP next generation fibers at scale by Andreas Stoner. The fourth one is Side hyperscale textile to textile recycling by Dennis Noblius. Let's start the first presentation by Oliver. The floor is yours. I think you can sit over there and make, no. Sorry. Let's give a big round of applause.
Hi, my name is Oliver Shafat, and I'm the founder of Siloom Labs. And I want to start by, thanking the ITMF, the Uzbek Textile and Garment Industry Association, and everybody else for having this wonderful conference and giving me a chance to tell you a little bit about what we're doing with our product we're calling Bylon, which is a fiber that can look, feel, perform, and most importantly, cost the same as what we're used to. We've seen this, or a figure like this before, where we make over 100 million tons of apparel fibers every year. And if you look at the breakdown of preferred fibers, whether that's recycled polyester, organic cotton, certified man-made cellulosics, there is a large shortfall. And of course, there's been some lively debates about what preferred actually means. And I think that that's something that we need to continue to have in this discussion. But what's really apparent is that from creation through use and at end of life, the fiber industry is emissive. And we need change, and we need to meet this shortfall, and we need the innovations that are required. And that's what we're trying to do with Bylon, where we're proposing a solution that allows us to provide a fiber without compromise. And we've done this by designing our fibers to use scalable bio-based feedstocks. So feedstocks that we can use to meet the demands today, but also the future. And we can take these feedstocks and drop them in to existing infrastructure today for the reactors, the separations techniques, the fiber processing, which allows us the synthetic versatility that we're used to with man-made fibers, but also we are a new polymer, so we have some value-added natural properties as well. And as has been mentioned a lot throughout this conference, the end of life is something we need to start thinking about as well. So we've designed Bylon to be recyclable, but also when it does end up in the environment, like most fibers do, it won't persist there and it'll degrade without a trace. And we can do this because Bylon is built on incredibly efficient and scalable chemistries. It's a simple process where we can take a variety of industrial agricultural byproducts and drop it into a reactor to isolate out our intermediate, which we can then further valorize to our monomer, and we polymerize it just like you would nylon or polyester into a thermoplastic. And what's really cool is we're using chemistry throughout this entire process. This allows us to be a little bit more agnostic in our waste stream. We can take spent grain from brewing beer, but also coarse wool fibers or wool fibers that can't be respun. And what's really cool is each of these steps is separate. And so we can advance and mature the technology separately, but it's all designed to use the infrastructure that exists in the current petrochemical industry. So we can drop into those same reactors, we can drop into that same separations techniques or the processing, which means that we will be able to use the benefits of efficiency that ultimately have economic benefits. And it's not just important to make a thermoplastic fiber. We've been able to melt spin this, the most efficient, quick, cheap, easy way to make yarns. We can tune the filament count, the diameter, and so on, just like we do already. And our first yarns were able to be knit without a problem, and our initial dyeing and finishing, we've been able to achieve relatively good results so far. And we are early in our development process. We are up here for the startup. Let's see if this will actually go forward. There we go. And we've only started to just characterize our material, but a couple of points that I want to highlight is the moisture regain of Bylon is about 8 or 8.5%, right around where cotton is. It's very different from your standard synthetics like polyester or even nylon. And I think that this can have some really interesting implications in the use case of it. And while early, we're still able to achieve strengths that allow us to further process our yarn. And with some offline processing that we've done with some of our first yarns, we can reach the commodity synthetic strengths as well already. But it's important to remember end of life. We've heard a variety of different stats throughout the Congress. 90% of fibers end up, landfilled or incinerated, 1 garbage truck per second. And I think it's important to remember that it's going to take a lot of innovation and a lot of technology and a lot of impact in order to change that mentality. And so we have started by designing Bylon to degrade when it does end up in our environment, whether that's through use, through shedding, through laundering, or if it gets thrown away at the end of life. And I think that's incredibly important so fibers do not persist forever. But as we will hear later, recyclability is also very important. And so we have conditions that we've identified where we're able to chemically recycle Bylon under incredibly mild conditions. And actually some results we got in since we've been in Uzbekistan is we've simulated sort of some recycling, and part of the apparel recycling problem is it's a mixed material. You have polyester, you have cotton, you have spandex, nylon, and so on in that, right? And it's really hard to develop technology to recycle everything at once. And so to simulate this, I sewed on one of our Bylon knits on white onto an old pair of cotton jeans I had with some polyester thread. And in very mild conditions and relatively quickly, that's completely unoptimized, we're able to depolymerize Bylon and separate it from a relatively undamaged cotton and polyester sample, which we could then hand off to some of our colleagues on the stage here. I think that that's really exciting. But none of this matters if we can't meet the cost demand, right? Because ultimately, adoption won't happen without cost. And so by using low-value byproducts of the agricultural industry, but taking advantage of the reactions, the reactor separations techniques that really give polyester and nylon that economic advantage, we'll be able to scale quickly, but I think most importantly, keep our costs down so we can actually become a viable solution and you don't have to compromise. You know, in the next 5 years, we're rapidly approaching a lot of brands' ambitious and necessary sustainability targets. But there's this huge gap. And we've heard how much, you know, the industry is growing, so it's 20, 30 more million tons by 2030 that we're going to need to provide. And that's where technology, where we hope technology like ours, as well as others who are being developed, will be able to assist. And so we've designed Bylon to slot into the industry as seamlessly as possible, where we can take sustainable bio-based feedstocks that are scalable, make polymers, make yarns, and then hand them off. But also we've developed the technology for the fledgling recycling industry so we can make sure that we will be able to, you know, provide an answer that is, allows the industry to become more sustainable, more circular, whatever you want to call it. But we also can't do this alone, and it needs the entire industry working together. We are a startup, we're a small, you know, a small player right now, and I've been very excited to hear sort of the commitments throughout this conference about how we are going to make that transition. And so that's just a little bit about what we're doing, and I want to, again, thank the ITMF for this award. It was a pleasure to come speak up here. Thank you.
Thank you. The next speaker will be Psychotex light films of topological soft gel for thermal insulation by Sinin Mao.
You push. Hello, okay. Hello, good morning. I'm Sinin Mao from Beijing, China. On behalf of our startup company, to give us our recent development work on the new material. Also, we are pretty honored to be nominated, awarded by this startup company. Thank you for the ITMF and the IAF, and hopefully this is our first time to be here, you know, in this great country and very beautiful, and also a lot of kind of history about the silk and the other linen, you know, clothing materials. We are a new company introducing a new technology. I'm going to share more with you. Okay, as you all know, this is 1,000 years history, maybe 10,000 years history about keeping our body warm, right? It's different from animal. Our human beings, they're all the cotton and any other like a fur. And recent years, a couple hundred years ago, we started using down, but they are very thick, heavy. And maybe in the past couple 10 years, we got some artificial materials like fibers, other chemical, synthetic materials, as you all know. But right now, we are introducing another new material which can give us a much different behavior and also kind of experiences. We call it Psychotex. It's a brand name. That's a three-dimensional porous material. You can call it film or membrane in the you know, technical society. This is basically what we have. It's not a fiber, not a fiber flake. That's a thin layer. But it's quite warm in some sense, thermally insulated. This 1 millimeter thick material can equally produce the same type of heat resistance as 1 centimeter thick down material. So you can have, like, let's say 5 to 10 times thinner material. That enables us to give a design, fashion industry very good choice to get a better, like, you know, S-curve or beauty and other things. And this is a material we produced in China. Our company was established about 3 years ago, and we have 40 people since the startup company. We also have a factory in Guangzhou and Shanghai, other cities in China. We have 3 PhDs and 10 master degree engineers. Also, fortunately, we got some capital investment, such as very famous Sequoia investors. We have commercialized this material in China and also globally. We produce more than 10,000 Chinese yuan already, the sales. And for the next couple of years, we are expecting more coming since the demands are very strong. Hopefully, in this meeting, we can get to know partners and friends. We can develop and promote this worldwide. What is topological soft gel? This is a porous material, and as I showed you, and it's a microstructure, has a very layered structure, a lot of closed cells where you can keep the gas, and also frozen. You all know that's the physics of keeping the materials thermally isolated or thermal conductivity low. Also, we add some composite like so famous nanoparticle for aerogels. Also, the micro capsules of phase change materials. So we mix them up, make a composite material. This is not a one material, it's not nylon or polyester, it's not a single material, it's a composite, multi ingredients inside. Importantly, we have to keep this suitable for clothing industry. You can have thermally insulated material for construction industry use. That's very common. But for clothing, it's hard. First, we want to keep the stretchable. So it's a highly stretchable implant, 4 directions. Also, we can, okay, a little more physics. This is the kind of physics. You all know there are 3 channels for thermal conduction reduction. As the radiation, there are lots of radiation from body to the environment. We add some special elements or nanoparticles to reduce that. And also, we try to make the convection low and also thermal conduction through the solid area. So we have this very thin wall area which can reduce the thermal conduction in solid paths. So basically, this is what we did. We got very low thermal conductivity, which is good for, steel air is pretty good thermal insulation material, but our material is like about the same. And also, well, you all know we got the thermal conduction low. Well, we don't have the permeability for air or moisture, but we keep that also pretty good air permeability. And as waterproof, more importantly, the washability. We got easily 20, even 50 times after washing, either dry cleaning or using the machine washing, our thermal property still keep the same. That's very important. Of course, green is always important. We are environmental and human safe. We passed the ICS 248 substance of very high concern based on European chemical standard. Also got Ecotex certified. Of course, there's some Chinese national standard. It's good for children and infants as well. So based on such good superb properties, we got lots of awards, and including Geneva Invention Gold, Nuremberg Invention Gold last year. Of course, China Excellent Patent last year, and also, more importantly, the ISOP, we got, for the past consecutive years, every year we got some progress. The first time we went there, we got top 10, and the second year we got type 5, and last year we got the best product, it means top 1. So far, we have more than 10 Chinese patent, also US patent, invention patent issued. Total, including trademark and software, other things, we are more than 90 IPs. Okay, more importantly, we are not the material only for fading use. We can make it a composite, one layer, laminated. For example, this material we can use for stretchable like yoga pants. And this also important, we can combine this with silk. Okay, that's one layer, thermally where, thermal conduction low, so we can keep it thermally warm. So the lady, the CEO of a company, Mrs. Duan, she's wearing this material. She can wear this in Beijing in winter time. Think about that, okay? That's the beauty of this material. Also, we have a variety of forms. So we can make a single layer, multiple layer. We can combine this with some even fiber flakes, which make our conventional customers or partners. We're not making clothes, but we supply material. We're more like a tier 2 type of supplier in that sense. So we can combine them and make a thin, light, and thermally very good. It means the heat resistance good for replacing certain type of like down or fiber flakes. Okay, as I said, we can combine this with the traditional material, cotton, linen, silk, wool. Also in other areas like the logistics, the cold chain, other areas. Okay, finally, thank you, and this is our contact. We hope this material can revolutionize the textile apparel insulation for the next couple years to come. Thank you.
Thank you for your good presentations. Let's move on to the third award-winning startups. Re-up Next Generation Fibers at Scale by Andreas Stoner.
Hello, everybody. A lot of PowerPoint. I want to give you some energy. Before I start, get up. A little bit of energy. Come on. So many PowerPoints. So, come on, all of us. Before we start, up, up, up. It's your energy. You get it. I promise. Okay, all up. You follow me. Like this. 1, 2, 3, 4, 5, 6, 7, 8. Other foot. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 2, 2, 2, 2, 2, 2, 2. And then 1, 1, 1. And now very fast, all with me. Are you ready? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 4, 4, 4. 4, 4, 4. 4, 4, 4. 4, 4, 4. 2, 2, 2. 2, 2, 2. 2, 2, 2. 1, 1, 1. Okay, energy. Okay. I want to save you. Now it's fresh. You can. It's more relaxing. Okay. Sorry, we have to start again.
You have one minute of extra time.
Yes. Okay, thank you. Was it worthwhile? 1 minute more? Okay. My name is Andreas Storner. I have a 15 years experience in fibers, in man-made cellulosics, and now I'm with Re-up here. I moved from a big producer. Why? It's so exciting, recycling. This is also my word to the, thank you very much to the board of ITMF, IFA. Thank you very much. I want just to send a message. Think about, in the future, having a recycling panel, deep recycling. You have the knowledge in technology, machinery, fibers. I think that's the forum worldwide which can bring everything together. Food for thought. So, recycling, Re-up. It's a company based from a 120 years old traditional company, Sanko Holding. 1 year ago, I had the great opportunity to start in recycling. What is recycling? You know, I will go through, you can see everything. Today we know we need recycling everywhere. We are the only one, the only company who can separate cotton, polyester. We can remove from the cotton, we keep the cotton. We move out the color, the polyester, and the elastan. We keep up this wonderful white cotton. So we sell white cotton to the market and polyester chips, textile to textile polyester chips. We have already 80,000 tons capacity. We are scaling up this year for 200,000 tons. And this is unique. So we're the biggest textile recycling company in Europe now. We are ready with 80,000 tons. We have all the separation technology developed. We started in Turkey, now we're looking into Spain. We build a plant. We have discussions with Morocco. We want to go further even to the Asian market. And I think here is just the process, very easy for you. Don't want to bore. We can reuse post-consumer waste, post-industrial waste, and production waste. And I think here's the technology. Europe has 80 million tons of post-consumer waste. 8 million tons. You heard from Dirk yesterday, where it's not possible anymore to send it somewhere. So that means let's use this fiber, let's use this raw material in all countries, in Asia, in Brazil, in Central America. Let's use these technologies to use it. So we get post-consumer waste, pre-consumer waste, production waste, and this is the re-up technology. As I said, we separate, we keep the cotton, white cotton, we do remove the color, remove the elastan, and remove the polyester to have an output of pure white, proper white cotton. Cost-wise, is cost neutral. So the Cotton A index is our pricing, just to share with here, not more details. And that's also new, we have textile-to-textile polyester chips. As you know, the bottle industry, the packaging industry, they want to keep their fiber with them. So we need to think textile-to-textile. And this was also a big effort to do that. And these polyester chips are also having high demand, especially in the activewear industry. So I think that's the picture you should keep in mind. Of course, the PowerPoint is then available for everybody. So post-consumer, post-industrial waste, unique technology. This is patented. We have a patent on this. It's called re-up technology to move this out. In the end, this is more detailed, too complicated. If it's more cotton-rich, we do the cotton fraction. If it's more polyester-rich, the polyester. And I think this is the main important topic here for you all. I want to show it's not just a paper company. We have, as I said, 80,000 tons available today. We are scaling up the next 12 months to 200,000 tons. We want to go for 1 million. These are all pictures from our facilities where we already run. We're scaling up. It's already there. And sustainability is very important. We hear it. What is it? We thought we take it, first of all, we take it very serious. Quantis helped us to do an LCA. Even the company is very young. You can see next cotton in the next gen polyester, 80% less water than virgin. Climate impact, approximately 80% less. Land use, similar. And in cotton, we have 90% less water. And I think very important is we have a lot of growers here. They need to keep also the land for additional crops, food. The land use will be reduced by 90%. So that's the key message. This is quite good also from the environmental impact. We did this with third party. We have the verification now again doing. And I think these are the key topics I wanted to share with you on this presentation here. It doesn't work very good, but we know that. And again here, I want to say 80,000 tons capacity now. 500,000 tons is our aim midterm. In the moment we go from 80 to 200 and 500, and then to 1 million. And we know Europe is post-consumer, clear. But to grow, we need to go to Asia. Middle East, Asia, these are the big things. And we want to really to go there. We are looking into first glance of India, but we want to, this is the way to go. We have a big opportunity. We are all here. We all here have the same challenge that post-consumer and post-industrial is a feedstock we need to convert. So you see me and my colleague Özgür is over there. You see him on the table. We are very pleased, Özgür. He's my best friend and he's the commercial director. We are happy for all discussions later on. I wanted to not bore you. First, energize, small message, and thank you very much.
Thank you. Let's move on. The first presentation, hyperscale textile-to-textile recycling by Dennis Nobelius. Dennis, the floor is yours.
Thank you very much. So I'm Dennis Nobelius. I got 0 experience in textiles. And the reason why I mention that is that I'm here to scale, so that's my expertise. And I'll talk about Syre today, and I will steal 1.5 minutes of my slot here to show a video. So I would like to start a short video, 1.5 minutes. Please bear with me.
Textiles are a part of our everyday life. But the way we produce and consume them must change. Vast amounts of textiles go to waste every single day. It's a growing global challenge. The textile industry accounts for up to 10% of the global CO2e emissions. That's why we have founded Syra. Syra marks the start of the great textile shift. We want to decarbonize and de-waste textiles, starting with the world's biggest fiber, polyester. We are implementing textile-to-textile recycling, putting textile waste to use over and over again. Our vision is simply a world where every textile is used again and again and sees a new day. But what really sets us apart is our groundbreaking technology that lets us turn end-of-life
Thank you very much. So, we are a textile impact company. We're here to collaborate. We are focused on decarbonization and de-wasting. We're searching for partners. We are really at the hyper-scale approach. I'll touch more upon that because that's how the entire company was set up. Let's see. One more, please. There we go. Yeah. Could you please back up one? Or maybe I do that. Yeah, super. So this is so interesting, I think. And this is also why I decided to join and lead this venture. It was started by H&M because I saw that I put a lot of investment into smaller companies, but none really scaling and making an impact on their sustainability targets. So they said, let's start this company, let's bring other investors on board, let's secure how we can really scale this on top. As part of that, we also negotiated for almost half a year last year a commercial offtake agreement, which we are very proud of and creates a foundation for us moving forward. So H&M actually committed 50% of all the forecasted polyester volume for the next 7 years to us as one company, which is really great, and we appreciate that a lot. What other things? I mentioned that we are different in a way. We are different because we are set up with a financial structure, with investors, and a technology that is all focused on scaling. TPG Rise Climate is one of the world's biggest green funds. They are joining in early on to be able to support the bigger plans that we're about to do. So all that is positive. We also focus quite a bit on getting 3 verticals on board, because we will not only work with apparel, but also with automotive and home interior. So here we got IMAS, which is part of the IKEA, and we have Volvo Cars, and also a German auto brand that is not public yet. But moving on, where do we stand right now? This is our R&D facility in Carolinas in US. So we cheated also here because we integrated and merged with a company in North Carolina, which has got technology that they worked with for close to a decade and already had moved from lab scale to a pilot line and then into this. So this is already in existence. We're also doing this in parallel. So we have this facility, we are moving into this one, and that will be operational by early next year. So just a couple of months ago, we decided and designed all the equipment since early last year, actually with the guy that built the plant in Renewcell. He has been leading that effort since we were in stealth mode. Christer is his name. And if I just touch upon the technology for a second. So it's a continuous process. It is just a few process steps. 250 Celsius degrees, which means that it's low energy use. Reusing the energy with very clever heat exchangers. Just 2 chemicals, both friendly, and which we'll reuse in the process, all aim to achieve low cost. Because to make an impact, it needs to be volumes. We're also looking into teaming up. So if I take the next slide then, this is right now us scouting for where do we build the big commercial plants. So we have the R&D, we have the 10,000 metric ton operational early next year, then we go for 250,000 metric ton plant in Vietnam. But we also recognize to be able to team up with you properly, we need to be where you are. So our plans is actually to have around 12 of those plants across the globe in all the regions to close the circular system. So I'll leave by that. And then, what else? I mean, we're focused on being on par with Virgin, and we can showcase that that is what we are. We are focusing on the regional chains to be able to be close where you are. We do not need to build further spinning or similar, because we can team up. There is spare capacity, and we can help you to increase the utilization of those. When it comes to the figure 12, that's the number of plants that we're targeting, but it's also the supply-demand gap, 12 million metric tons by 2030. And how do we reach that? Of pure textile to textile recycling. So if you have 60 million metric tons today, going to like 85, 90 by 2030 of polyester, we believe that there will be a gap around 12 million metric tons on that. And this we used an external consultancy, and they mapped then 450 apparel brands and their statements. They mapped the legislation, what is coming, that you heard yesterday. They mapped 25 of the top auto brands, and they mapped 27 recyclers and their planned capacity. And then applied, also science-based target, and then applied probability on that, of course saying that a grain of salt with the statement that is being made, and then reaching the 12 million metric tons. So by that I'm saying that there's plenty of space for all of us, and also to team up with you to capture this business opportunity. And how do we then do that? Because ultimately, it is all about people. So here's a few of those that we have engaged in Syre that is working for us. Some persons you probably recognize. So we have, of course, Robert van der Kerkhoff as an advisor. We have Camilla from Bestseller. We have Harsha from H&M. We have one of the founding team of Allbirds, the footwear brand in US, Jad, who is leading our commercial efforts. We have the guy that built the Renewcell plant, Christer, and so on and so forth. So we are very pleased to have that on board, and it comes from all different sectors. But my main message today is actually regarding collaboration. And I would like to end with a citation of the explorer Robert Swan. He once apparently was saying, "The greatest threat to our planet is the belief that someone else will save it." Thank you. I'll use the last 20 seconds just to showcase this is where we are right now. So this is made by post-consumer waste in our technology. Thank you.
Thank you for good presentations. Let's give us 4 presenters for big loud applause for their wonderful presentations this morning. For startups are very much convincing for the bright, prosperous success in the future. Before I go to the floor for the questions, I'll make one questions to all the presenters. Promoting the startup involves creating an environment that fosters innovation, reduces barriers to entry, financial support, infrastructure, so and so and so. So, based on your experience, what kind of promotion or support do you think are needed for your success? Let's start with Oliver.
Yeah, that's a very good question, because we basically need support across everything. We're a small company and we have technology that we're developing, but we need to work with the partners that have scale, that have that expertise in turning, let's say, our yarn into textiles. But it's also very helpful for us to work with partners that know the product is in development and are willing to develop with us. So maybe we're not good at X right now, so we can go back and fix that, but they can continue to work and tell us, what we could target with. And I think it's really that collaboration with small companies as well as the bigger, more established players that are going to allow us to get the technology and have the impact that I think we all actually want. Thank you.
Next.
So everybody has to talk? Okay. I think I used to work for a big company, giant in the United States, Western Digital. But when I went back to China with my friends, we built this small company. We just feel it's terrible. I won't do it again. But since we did it, we want to just finish the job, okay? I think you just mentioned we need help from everybody. First, you need to have a dream. You want to have a startup, you want to change the world, right? You want to do something for human beings. If you just want to make it simple, make money, I don't think that's a good drive, goodwill, okay? Then there's old Chinese saying, 天时地利人和 means the timing and the location and the people. That's the three elements from 2,000 years ago. People said that we feel that's the same way. We want to keep that way for the next, for the future. So we are very confident that we can make it successful. Thank you.
Thank you. Okay, Andreas?
Yes, I think we need to think a little bit more holistic. To change from a linear system to a circular, it has more levels. We heard legislation, feedstock, operations, and of course downstream. I think the one is, it will come from linear to circular. I think everybody, 80% of the room is committed will come. When it comes, it depends. And I would say the biggest support from our side is, just to say the biggest thing is that we have a wonderful chairman with Fatih Konoglu, who was the thought leader and believes in that. I think it's very good to have a strong partner in the home company who helps you. In the moment also Sanko and ISCO is the biggest customer we have. This helps a lot. The partnership of innovation always needs a strong, solid partner. I think that's a very good exercise. But the challenges are very everywhere. Technology needs to be developed and all of that. And I think that's the exciting part. The exciting is textile, the next 3 to 5 years, I would say is the most exciting time we always were in, because it changes from linear to circular, recycling gets in. I think it's a great thing. Looking from today, in 3 years, we will have completely different solutions. We learned much more, and we were more excited, and a big learning curve, like the industry always learned quickly than everybody.
Okay, thank you. Okay, I want to ask one very simple question to Oliver. Byron is the bio-based plastics fibers, something, it belongs to the something similar to the polylactic acid of a polyester, or it is cellulosic based? Can you specify?
Yeah, that's a good question. So we're actually would be classified as a polyamide based off of the polymer structure. But we are able to be bio-based as well as have responsible end-of-life versatility.
Thank you. Okay, now the mic goes to the floor. Anybody have questions? Please raise your hand.
Hello. First of all, I congratulate all the partners there for this great efforts as the startups. My question, by the way, I'm Özgür from Riyanup. My question is for Mr. Mao.
side cortex. So, I mean, for insulation, what is being used today globally is mostly the hollow fibers, okay, with the or quattrophil or hollow fibers, which has the hole inside so that it creates the insulation. So when it comes to your technology, how affordable that system is compared to the hollow fiber paddings being used in the apparel industry today? And second, how we can implement your technology to the apparel industry, like denim, for example, okay? I mean, so this is very good technology. It can create a kind of, the whole thermal comfort through the whole year. So I just want to have that, I mean, how we can implement that technology to denim industry, for example. Thank you.
Thank you, very good question. I didn't mention the cost. Of course, when we first introduce the new technology, the cost will be higher. I think just show the cost down curve, we are going to reduce that. In terms of total cost of our material per square meter, it's about the same as the material used for down jacket, not for fiber flake. Fiber flake is very cheap. We're not comparing with the 3M or Insulate or Primaloft, that kind of flaking or fading materials. I compare the down material, for example, I think last year you all know the price jumped 3 times. So there are a lot of business need, honestly, want to use this material for current design or clothing industry. We saw that. Second one is the current implementation form, or right? Your second question is?
How we can implement your technology How to implement it into denim.
Oh, okay, denim, yeah. I didn't, that's a little too cold. In winter, I wear jean in China. We got 3-layer lamination. We already use it for laminated material, okay? That means the jean, we can go through the jean process, the acid, the oil washing, very brutal mechanical process. That can be done already.
On the floor on the left, please. Mike, please.
Thank you very much. Navdeep Sodhi from Jersey. My question is both to Andreas and also to Dennis from Syre. So the question to Andreas is, you are separating the cellulosic and the synthetic. So as far as the cellulosic part is concerned, that is cotton, from what you have produced so far, what is the length of the fiber you are able to achieve, the optimum length? And second is there a cellulosic material like a powder as a byproduct that comes out? Can it be utilized in the cotton field to improve the yields, etc.? And the question to Syre is, the major issue in textile recycling is energy. Although you mentioned your process is energy efficient, but could you please elaborate on that a bit? Because that is really the bottleneck. Thank you.
All right, thanks. I got the offer here to start. So energy is the key, and that is also what the professors have been working with for the last 8-9 years. And the way to use it is actually to use very clever heat exchanger, to use oil as that we found out as the carrier of the heat. And you can say that from the start, 5, 6, 7 years ago, then the heat exchanger was like the size of a conference room. And we managed to now get it down to very handy small units to really perform with that. And then it's great, this circular, so you can really design the entire layout to optimize the energy efficiency. And of course, we're going for green energy in all its formats to secure that we can really deliver an LCA value that is unheard of. That is what we have in the current plan. So thank you for that. And maybe also one more comment, because you mentioned the textile industry as being the most interesting one. And that's why I joined. I was previously in automotive, seeing the electric cars happening and seeing that is a big impact on the industry. But seeing what textile is actually facing right now in the next coming 3 to 5 years, I think it's so interesting, and I would like to be part of that. Over to you, Andreas.
Thank you. My answers are very short. The length of the fiber is in average 22 millimeters, but we all know cotton is not always clear. So we have a fraction between 22 millimeters to 26 millimeters. The shorter fiber is around 6 to 10 millimeters. This goes mainly into non-wovens application. And thank you very much, Mr. Sodi from Gerzi, about the question. There is powder, of course. There's the shorter fibers going to cellulosic powder, and this is a post-consumer opportunity for pulp and man-made cellulosics. Thank you for the question.
Okay, time is up, so we'll take a last one. Okay, then we'll wrap up this session. Thank you for wonderful presentations, for all the award-winning startups, and thank you for everybody on the floor. Let's give them the big applause. Thank you.
Good morning, please. I invite you to the ITMF Winners of Innovation, Sustainability and Cooperation Awards to join me on the floor, please. That's fine. Hi. Good morning, everyone. We just start now the next session about the winners. And please allow me to introduce myself for a few moments. I am Juan Perez, President of the Santanderina Group in Spain, and also Vice President of ITMF. It's a pleasure for me today to present the winners of this new edition of the Prizes of Innovation, Sustainability and Collaboration. Winners of Innovation and Sustainability Awards has been the company Wuhan High Technique Fiber Company, also YirikX Creation France, and iconic Switzerland. I want to say some words about each one of them and start by Wuhan High Technique Fiber Company is the transformation CO2 in PET fibers. Jiangsu 11 leads sustainable innovation in textiles. The project by Jiangsu 1 High Technique Fiber Co. aims to transform industrial CO2 emissions into high-purity ethylene glycol, which is used to produce low-carbon PET fibers. This innovative approach supports global sustainability goals by significant reduction of gas emissions and promoting a circular economy. The project's achievement include the development of first industrial-scale production line covering CO2 to PET fiber. Hyperscaling iconic is the second one, is a revolutionary textile with sustainable climate-positive filament yarn technology. The objective of HiQ and NIQ is to address the environmental issues caused by polyester and nylon in textile by developing a sustainable alternative. This innovative fiber, made from renewable cellulose sources, mimics the physical attributes of polyester and nylon without their negative environmental impacts. It uses 100% renewable energy and 99.5% closed-loop manufacturing process, making it biodegradable and reducing methane emissions. The next one is Samsara Eco. Samsara Eco transforms textile recycling, cutting carbon, driving through circularity of fashion. Samsara Eco, as an Australian environmental technology company, has pioneered EOS Eco, an innovative recycling technology addressing the global plastic crisis. The project focused on converting complex plastics like nylon and polyester back into their original monomers, using plastic enzymes, enabling endless recycling without reliance on fossil fuels. Now we go to the International Cooperation Awards, and the winners are YirikX Creation from France. This is an innovative collaboration between YirikX Creation and the German Institute of Textiles and Fiber Research, Denkendorf. This application showcases a groundbreaking project, Irony, which focuses on developing next-generation cellulosic filaments from hemp using advanced hypercell technology in the spinning process with a commitment to sustainability. This initiative aims to reduce the carbon footprint associated with the traditional wool pulp fibers. The second one is the Hong Kong Research Institute of Textiles and Apparel, ickita, in collaboration with H&M Foundation. It aims to provide agile solutions for textiles, apparel, and fashion industries to address climate change. Open Lab serves as a dynamic hub for innovation, focusing on sustainability and circular economy practice within textile and clothing industry. Overall, Open Lab is positioned as a transformative force in textile industry, promoting sustainable practices and innovation to reduce the industry environmental footprint. I should ask a round of applause for all of them. And just now, start with the presentation of Mrs. Wan. It's your time. Please go ahead.
Dear friends, dear colleagues, ladies and gentlemen, good morning. I'm Wang Rui from Beijing Institute of Fashion Technology and Guowan High Tech. I'm honored to be given the opportunity to introduce our project. My presentation today is about low carbon and sustainable innovation in the polyester fiber industry. As we know, environmental conservation has definitely become a major challenge faced by almost all industries, especially the manufacturing industry. According to data from the United Nations Environmental Program, 10% of the total industrial carbon emissions is from the textile and apparel industry. It is only below the other industry. With population growth, the textile industry might be on the way to becoming the top carbon emitting industry. So low carbon, green mode, and sustainability will definitely be the key point for the future textile industry. A life cycle assessment analysis conducted by the Federation of Indian Chambers of Commerce and Industry. The textile and apparel chain is divided into 8 stages, including fiber production, yarn production, and fabric production, dyeing and finishing, garment manufacturing, distribution and sales usage, and the final disposal after use. Notably, in the carbon emissions, the fiber production stage is at third or fourth, accounting for 12%. Obviously, the carbon emissions is mainly from the production of synthetic fibers. I will introduce the chemical fiber industry in China with some supporting data. There is no doubt China holds the largest market share in the production of chemical fibers, accounting for about 70% of global total chemical fiber production. According to statistics from Chemical Fiber Association of China, in the past year, about 68.72 million tons of chemical fiber was produced. Among these, the synthetic fibers account for 63.93 million tons, especially polyester fibers is 57.02 million tons, about 85% of global annual production. In the global apparel industry chain, China accounts for more than 50% of the upstream processes, including 57% of fiber, 64% of yarn, 60% of fabric production. Additionally, 44% of dyeing finishing and 35% of apparel cutting assembly are completed in China. China is the largest producer of fabrics, so the textile industry in China has an urgent need to transition to a low-carbon mode. That is the manufacturer's responsibility. The circular economy is gradually developing as a basic path to solve resource and environmental constraints and creating new economic growth points. This is driven by the dual carbon vision proposed by the Chinese government in 2020. Carbon emissions will be the peak by 2030, and carbon neutrality is be achieved by 2060. All industries in China are actively engaged in technological innovation. So we need to establish a sustainable and modern fiber industry characterized by high-end, intelligent, and green. Now, I'll introduce Guoguang High-Tech and Beijing Institute of Fashion Technology. We have been cooperating for many years, seeking the development of green and low-carbon technology for the polyester fiber industry. Guoguang High-Tech has advantages in the production of all kinds of polyester fibers. And Beijing Institute of Fashion Technology has advantages in the theoretical research on functional fibers and fabrics. We collaborated on the project about carbon recycling, achieving innovation on industrial technologies for sustainable low-carbon polyester fibers. More specifically, carbon dioxide first was captured from industrial emissions and purified to food-grade level, then chemically converted it into high-purity ethylene glycol. Through direct esterification with PTA, polycondensation, and metal direct spinning to obtain fibers, we established a production line for low-carbon polyester fiber. In this project, we have developed 3 key technologies. The first, we have achieved significant advancements in critical technologies for the capture and purification of carbon dioxide. The second key technology is chemical reaction to obtain high purity ethylene glycol and then fiber-grade polyester. The third achievement is metal direct spinning technology to produce low-carbon polyester fiber. Next, I'll show you the benefits and advantages of this program, of this project. Through the data, at present, the production of 1,000 kilograms of polyester fibers requires 335 of high-purity ethylene glycol, and approximately consumes 840 kilograms of carbon dioxide. Additionally, benefiting from the metal direct spinning technology, energy consumption is reduced by 37.4%, equivalent to reduction in carbon dioxide emissions of around 100 kilograms. Therefore, this route can reduce carbon dioxide emissions by 936 kilograms. The project, more important, the project demonstrates social responsibility and benefits in both energy saving and emission reduction. It serves as a leading and demonstrative role in the sustainable development of the textile industry. Also, it will promote the establishment of sustainable supply chains and co-building of low-carbon textile life cycle systems with textile and apparel partners. Finally, it can push forward the formulation of industry standards and accelerates the low-carbon transformation and sustainable development in the textile industry. Sorry. In conclusion, I believe that low-carbon mode and sustainable innovation will be the new textile road and also the powerful driving force for technological upgrading and progress. Let's work together to reduce carbon emissions, to recycle the emitted carbon, and to build a better world. Thank you very much.
Beaming up now. Can you give me first slide, presentation mode? Okay. Super. And one back. Can you go one back? Okay, super. Thank you very much. Wonderful to be here. Thank you very much for awarding us with this prestigious prize. My name is Carlo Centonce. I'm the co-founder of the HiQ Group. What am I here to talk to you about? About HiQ Aeonic. HiQ stands for high quality. Aeonic stands for eons, the ages of Earth, because we want to make materials circular. And in this case, we want to make the origin of our industry, fibers, circular. And I'm presenting you a high-strength cellulosic filament yarn, replacing in future polyester and nylon. Okay, next slide, please. Seems not to work with the click. Okay, one back. So 2 years ago, some of you remember that I was in Davos, and I talked to you about our ambition to stop mankind from wearing oil. Well, now I'm actually walking the talk. I'm wearing the shoes. I'm happy to present you the Change sneaker collection from Hugo Boss. Next click, please.
Through the Change, Boss creates pieces with a better planet in mind. Our cutting-edge sneaker is the first made with HiQ Ionic. Using less fossil fuel-based materials, it offers durability and high moisture management without compromising on style. This is the future of fashion. Boss, the Change.
So I want to remind you, problem statement. What is the problem? The problem is that we are producing an immense amount of textiles every year. And most of this, as we will see, is synthetics, polyester. A lot of that lands in oceans, in post-consumer waste streams. We have 35% of global plastic today coming from our industry, the textile industry. By 2050, it's estimated that we will have more plastic in the ocean than fish. Next click, please. And next one. As you can see, we have an immense amount of synthetic fibers, 80 million tons that are being produced year by year. I remind you, 1% of textiles is recycled today. The rest ends up in landfill and incineration. Changing this will take decades. Polyester has a big downside. It takes 1,000 years to degrade in these landfills. And we have no opportunity to grow more cotton or more wool, because with climate change, with growing population, we need the land to grow food and not textiles. Next slide, please. So, what's the approach? At HiQ, problem statement, how can we develop a solution with innovation? And this is what I'm presenting you, HiQ Aonic. It's a nature-based fiber with the same performance characteristics than synthetic fibers. What can we do? We are taking a benign solvent that we created at HiQ. We are taking sustainable cellulose feedstock, more to that on the next slide. And we're creating a fiber that has high tenacity, high elongation, and also no fibrillation, which is essential in our industry to recreate what polyester can do. This enables us to go across a wide range of market, from apparel to sneakers, as you can see, to home textiles, to industrial textiles, to automotive textiles. Next slide, please. Just to show you one of the USPs and one of the big issues that our industry in man-made cellulosic filament fiber has had for many years, fibrillation, preventing the use in many cases of application, but also the texturization of fibers. We've overcome this downside and have no more fibrillation on our cellulosic filament fibers. Next slide, please. Feedstock. Climate change means we need to mitigate and adapt to this change. And if we are taking forests and cut forests to make fibers, we're not solving the problem. So we need to find a way to use waste feedstock, not from forest, but actually from our own industry. We saw that before. The circularity with cotton fibers, textile waste. But more importantly, and available in immense quantities, is agricultural waste. We extract from the waste of making rice, ananas, sugar beets, whatever you want, everything that is green, we can extract cellulose, and we can use that as a feedstock with the HiQ Aonic technology. It's available in 50 times more than our industry actually needs. One step further, food waste, another big problem that our society has. And also here we are advanced in bringing food waste and making cellulose with bacteria out of food waste for our technology base. Next slide, please. Now briefly, with Aonic, we are giving a very unique sustainability profile to our industry. We can use 100% based waste feedstock. We have the lowest CO2 footprint in the industry, and I like to stretch out, we are enabling what is a Scope 3 science-based emission reduction, and also carbon credits that the brands can take on. They can lower their CO2 footprint by switching to our fiber. It's eternally recyclable. That's a big downside of other cellulosic fibers. We can recycle Aonic on and on again. And it's 100% biodegradable, and touch to believe, I show you a video on the next slide, please, of our biodegradability in just 12 weeks. Next slide, please. And click. One back, please. So what you see here is a biodegradation experiment. Very simple. On the left, polyester, then polyamide with lycra, then Aonic fiber with the label with lycra, 6%, then 100% pure Aonic, and all on the right, 100% cotton. Just water it every day, take a picture every hour, and you can see that after 2 months in the middle, Aonic is almost gone. After 2.5 months, it's definitely gone. You see only the white mesh, which is lycra mesh, that stays. But in 3 months, we are fully biodegraded and gone in landfills. 80 million tons a year instead of polyester for 1,000 years. Next slide, please. Innovation. But in our industry, you need to be fast and you need to be pushing hard. So differentiation, market validation is key. Next slide, please. That's what we did with Hugo Boss, who invested very early on, a visionary CEO who sees that we need to change our industry. And we have produced for apparel, for sportswear, for fashion, and now also for sneakers, the first products on the market that can be purchased. So it can be done. Next slide, please. And just for the Olympics in Paris, we were able to launch world's first biodegradable sneaker. Next slide, please. Now, the third thing you need to do is enable for scale. Here comes the difficult part in our industry. We are very capital intensive in textiles. Change is not easy. Our margins are stretched and slim. Nobody wants to drive change for good. Next slide, please. We're doing. So we built the first plant in Austria, 100 tons capacity, research in Switzerland, and now we are building our first factory in Portugal, 2 kilotons. One step up, the next level. And already planning a 20 kiloton plant, also in the vicinity of Europe, our first mega factory, and are thinking and dreaming about our 200 tons kiloton plant in Asia that should come in grid before 2030. We're really focused now on scaling up on the blueprint of our new technology, on bringing it to market with our brand partners. Next slide, please. So we purchased land and building in Portugal, 20,000 square meters for the first factory. We're on track with kickoff and completing the financing in the next quarter. We are running on a commissioning timeline of 24 months. By then you will see our fiber in the market at market selling prices for specialty fibers. No overpaying. That's also key for innovation in our industry. We need to fit the market price. We know that. Next slide, please. So lastly, if you want to win, you need a Champions League team. And we built one. I'm happy I could convince Julian Bourne to switch from CEO of Lycra to CEO of HiQ Ionic. I'm happy I could convince Robert van de Kerkhoff to become our chairman. I'm happy I could bring Christian Dressler in from Lenzing and Martin Gebert-Germ and Enrique Herrero from Glanzstoff. So we have a kick-ass fiber team on the starting blocks to scale this technology up and change our industry. Next slide, please. And here's a message to you. Please join our early stage investor, MAS Sri Lanka, Hugo Boss, the Lycra company. We need our industry to pull together to drive change. It's tough, it's capital intensive. We do foresee the opportunity is very interesting. The addressable market by 2030 is more than 10 billion. The total market is obviously a big crown. It's 100 billion if we replace polyesters in future. We will work with healthy EBITDA margins in our technology setup, and we are looking forward to bring in more investors into this ambitious initiative to change textiles. Thank you very much.
Good afternoon, everyone. My name is Dr. Vanessa Bongsuthi, and this is my colleague, Dr. Matthew Spence, and we are the research co-founders of Samsara Eco. I'd like to start by thanking the ITMF and IAF, as well as the sponsors and organizers of the convention, for the award and for the invitation to speak today. It's truly an honor to be here all the way from Australia and share the stage with so many other companies that are paving the way towards a more sustainable textiles industry. When many people think of the plastics waste crisis, it's usually single-use straws, bottles, and packaging that come to mind. But as I'm sure we're all aware in this room, textiles form a substantial and interconnected part of this larger story on plastics, one that demands our focused action and innovation.
Over 9 billion tonnes of plastic has been produced to date. with textiles accounting for 11% of this total. Yet only 9% of our plastic is recycled annually. And when considering only textiles, this figure drops to a mere 1% of end-of-life clothing items being recycled into new garments. Low polymer recycling rates stem from significant technical challenges. Our current methods struggle to sort complex waste streams, separate blended fibres or mixed plastics, and remove chemicals such as dyes from these materials. Even when our plastics and textiles are accepted into the traditional mechanical recycling process, with each round of melt extrusion, the polymer loses some of its quality and structural integrity and must be increasingly spiked with virgin material, or it will otherwise end up in landfill with the rest of our waste.
Images like these highlight a very important and clear narrative about plastic waste. But there is another less visible narrative that they tell us, and that is one about carbon. We haven't just produced 9 billion tonnes of plastic to date, we've produced 9 billion tonnes of plastic to date from fossil fuels. The production of virgin polymers currently contributes to over 3% of global greenhouse gas emissions, and this is projected to increase to 15% by 2050 if we continue business as usual.
At Samsara Eco, we are tackling the plastic waste crisis from both a waste management and carbon footprint perspective. We're currently scaling our closed-loop recycling technology that can handle textiles, mixed plastics, and dyed plastics with no loss of quality in the product. Our goal is to displace the production of virgin plastics from fossil fuels, so that, and in the process of doing so, add real value to what would otherwise be considered worthless waste. So that when we look at images such as these, what we actually see is 9 billion tonnes of an incredibly valuable resource. And we're achieving this with the power of our highly engineered enzymes.
Enzymes are the blue-collar workforce of nature. They're the tiny molecular machines responsible for catalyzing the reactions essential to all life. Building on decades of data on how enzymes evolve and function, we can now design new-to-nature enzymes that have the catalytic properties we need them to have. So, at Samsara Eco, we've designed enzymes that can rapidly break down different polymers, including polyester and nylon, into the basic chemical building blocks that they're made of.
Here's how it works. We take your biscuit trays, textiles, and coloured plastics, and using our enzymatic process, we convert them into their constituent chemicals known as monomers.
These monomers are no longer identifiable as waste. They're simply a pure raw material identical to what we have to extract from petrochemicals today. And so we can, of course, repolymerize them into virgin equivalent resins, which can then be made into brand new products, with no loss in the quality of the products over an infinite number of cycles.
Importantly, a life cycle assessment has validated that our technology will operate at a reduced environmental impact and carbon footprint compared to the production of virgin plastics from fossil fuels at scale.
With our strategic partner and investor, Lululemon, we've now trialled and validated our technology for both polyester and nylon 6/6, producing world-first enzymatically recycled threads and garments. Excitingly, our first collection of polyester garments with Lululemon nearly sold out in just a few days.
To the consumer, these garments are no different from the products that we know and love that have been made from fossil fuels. However, they represent a monumental change towards a more sustainable future, one where the clothes that we wear belong to a closed-loop recycling system.
Since our founding in 2021, we've been racing towards our goal of making plastic infinitely recyclable at scale. It seemed like not so long ago that Matt and myself were testing new enzymes at the lab bench. Now Samsara is building its proof of concept facility in New South Wales, Australia, that will enable us to perform commercial scale trials. The facility will also serve as a blueprint for our first of a kind commercial scale facilities for both nylon 6/6 and polyester that will have the capacity to recycle 20,000 tonnes of plastic per year. And this is just the very beginning.
Our talented team of nearly 100 scientists, engineers and business people are gearing up to deliver infinite plastic recycling to the world. We have benefited from a tremendously strong founding partnership between the Australian National University, Australia's largest supermarket retailer Woolworths, and Main Sequence Ventures, who co-led our most recent fundraise with other strategic investors that closed at $100 million to support our acceleration to commercialization, scale up and expansion into new plastics.
Leveraging our strategic partners and investment, we're now accelerating towards our 2030 ambition, which is to recycle 1.5 million tonnes of plastics, including textiles, per year, preventing an estimated 2.5 million tonnes of CO2 emissions in the process of doing so.
There is a future where the polymers in our clothing, packaging, infrastructure and devices have infinite lifetimes. One where the plastics that we rely on come from the 9 billion tonnes already in existence and not from fossil fuels. To tackle the plastic crisis, we must give real value to our end-of-life plastics and textiles. And in the process of doing so, we have a genuine opportunity to minimise the impact that the production of virgin plastics from fossil fuels has on our rapidly changing climate.
If anything we've shared with you today excites you or you'd like to follow Samsara's journey, please do connect with us. Thank you so much for your time and attention. We're happy to answer questions in the panel session.
No, that's not us. That's not us, that's him. We are the other company, Research Institute. Yeah, that's me. That's us. Well, okay. Nice to meet you. One question. When you think of inspiration and idea, do you think of a spark that starts a fire? And a fire, it's a good thing. It keeps you warm. But a fire has a drawback. It burns everything down and it ends up in nothing. When I think of inspiration and ideas, I think of spring, which turns into a river, and the river goes to the ocean. And an idea can only become strong and a good thing if an idea meets another idea. And that's why we work together with Anne. Yeah, for sure. Seems so loud here. Well, so that's where our journey began, with a spring of an idea, to create a next generation cellulosic filaments from a different cellulosic source, in this case hemp, where irony and hypershell met. Our journey begins in Stuttgart or nearby Stuttgart at the German Institute of Textile and Fiber Research in Denkendorf. We were founded 100 years ago, and we closely work with the universities of Stuttgart and Reutlingen together, and many, many other companies and research institutes from all over the world. And that's why we're still here, because we keep working with other companies and other research institutes. Yeah, that's me. So I'm working at the Competence Center of Biopolymer Materials, which means in my center we only use renewable resources like cellulose, chitin, keratin, alginate. We only work with biopolymers drawn from nature. And to produce fibers or fiber materials, we started to look into smart and recyclable solvents, which I'm going to talk in a in a few minutes. And then we create, in the middle, we use those solvents, solved polymers to create fibers for textile and technical applications, or foils and coatings. And on the right side, you can see that we try to not only create textile for clothing, we also had a look into carbon fibers from cellulosic materials or into reinforcement for composites, but that's not the topic for today. So our technology, the hypercell technology, is about spinning cellulosic filaments, and therefore we use a sustainable and eco-friendly patent spinning process, which is based on an ionic liquid. The ionic liquid can dissolve the cellulosic material in quite a wide range, up to 20%, weight percent of cellulosic. We use several feedstocks, mainly wood pulp, but we also had look into other feedstocks like hemp. Our process is a low temperature process. We don't need any other chemicals for our process, just ionic liquid and a cellulosic material. And we are able to recycle our ionic liquid about 99% in several circles. Yeah, we also had a look into how our process is sustainable, where we can squeeze some things to make it more sustainable. And it's a good start, but we only have 3 compounds. Every single compound is either biodegradable or recyclable. We have a water-saving process because we recycle the water as ionic liquid, and we have a closed-loop process. And if we change the energy we use for our spinning, we can also only use green energy for the spinning process. That's where we met Anne from RBX.
Thank you, Mark. So I'm the co-founder of a startup, RBX Creation, founded in 2016. We are based in the southwest of France, and we also have an office in a farming cooperative in Normandy, which is a world-leading region for textile flax production, and now turning also to hemp. So our main activity under the trademark Irony is to develop new textile materials out of agricultural biomass, and especially hemp, with a different approach based on cellulose. And this is what led us to visit the ITF and start working on the expertise on cellulose spinning. So the collaboration started through a European one-year project called ELITE, whose goal was to evaluate the potential of our hemp cellulose pulp with the hypercell spinning technology and to assess the market potential of the resulting filaments. And it has been since then an ongoing collaboration with multiple tests and now a focus on upscaling. So this is a core project team on the right. So starting with the feedstock, why hemp? So hemp is a plant with many ecological assets. It grows in a few months only a dense biomass, so it acts as a major carbon sink. It's a resistant plant, so no irrigation needed. And another key fact is that there's 0 treatment between sowing and harvesting, either in organic but also in conventional farming. It's a crop grown in rotation, more or less every 6 years, and it leaves a clean and structured soil for the following crop. There are different ways to cultivate hemp, and these production models will impact the stalk's yield and whether the seeds, which are a great source of food, like proteins and omega, are harvested or not. In France, we are the first producer of hemp in Europe, second in the world. We always kept some hemp agriculture, actually, and now we reach for this year almost 24,000 hectares. Oops, sorry. So we built strong relationship with the hemp producers in France. We're part of a key network reuniting all these producers. As I said, we also have an office in one of them. no matter the production model, we can collect the feedstock. Actually, what's happening is that once harvested, the M stalks go first through what we call a defibering or scorching unit to extract the best fibers, which are going to go to paper, construction, or textile similar to flax or linen. And then there remains a byproduct, which is the woody core of the stalks. And this is about 50% of the stalks, and that's our raw material. We can use it alone or also in combination with other local feedstocks, such as flax or miscanthus, which is a type of reed. And from this raw material, we developed and patented process to get the cellulose. And in the cooperation with the ITF, we deliver the M cellulose pulp for evaluations and spinning. So I let Mark present the results.
So we were really excited when Anne reached out to us, and we first laid our hand on her pulp, and we decided to use the pulp because it was a high quality pulp. So as you can see, the pulp is high quality, and we used our spinning tries to produce many continuous fibers with different mechanical properties, reaching from really low elongation and high tenacity to more textile-like fiber properties, and also high young molars. So we decided to keep continuing working with Anne and her projects. It's yours.
So the resulting filaments are continuously testing downstream the value chain until some first and product prototypes with partner brands and designers, and also involving some textile manufacturers. So for the filaments, we're doing direct knitting and weaving, also previously some twisting on the filaments, also testing the stability with dyeing. So with the filaments, we're targeting high-end clothing, but also technical textiles. And filaments are also at the ITF turned into staple fibers with the goal to reach other segments such as casual wear by doing open end or ring spinning. There is more and more demand from brands as these fibers combine like technical and also environmental performance. I also have some samples with me actually if you're interested to see more. And to summarize, Hypercell meets irony. It combines traceability from the field, circularity with a sourcing approach, also lower impact as per first LCA, support to sustainable agriculture thanks to hemp, and high quality of the resulting fibers and versatility thanks to Hypercell spinning process. So thank you ITMF for this award. It celebrates 5 years already of fruitful collaboration with the ITF and collaboration which will continue to grow. And thank you all for listening. We're here for any question.
Good morning. Last presentation. I hope, like me, this morning we have become concerned about all the challenges in front of us, but also hopeful because of everything that we've heard this morning. And I hope you, like me, have been sitting here and have been in awe with all the good work that everybody is doing, those on stage and many in the audience. So I'm from the Hong Kong Research Institute of Textile and Apparel. We are a not-for-profit applied research center, and I want to talk to you this morning, or share with you this morning, about our recent project called the Open Lab. And so what is the Open Lab? The Open Lab came out of our frustration that it is taking too long to scale up some of the solutions that we see in the marketplace. Ours, the solutions we bring to market, and solutions that others have been working hard on. So what we want to do with the Open Lab is to disrupt the scaling process. How can we bring solutions to marketplace a lot faster? So the Open Lab actually officially opened last week in Hong Kong, and the most often asked question all of last week from everybody that came to the Open Lab event was, there. Why build a factory in the world's most crowded, most expensive city? Why would you do something crazy like that? Well, let me explain what we are trying to do. So the Open Lab has three parts. It is, first of all, a collaboration space. Whether we have solutions or other people have solutions, we want to work together so that we can bring these solutions, the technical solutions, to the marketplace. We are but one piece of a puzzle. That sitting on top of technical solutions should be strategic decisions that businesses should make about how to use these technologies and deal with some of the challenges that we have around sustainability, circularity, and climate change. We want to speed up the innovation process. We want to see if we can get things to industrial scale as quickly as possible. And we also want to inspire us to think about things differently. So the three parts of the Open Lab really is this collaboration platform for us to work together, and we want to bring as many people around the table as possible. We want to make available the resources that we have worked on as a research institute, but also solutions that others have worked on. We want this to be a place where we can all work together and put the puzzle together. And we said we want this to be a kitchen. This is where we all work together. We're not here to be served. We're here to cook the meal together. So it is a place where we can work together, see if we can make something useful out of what we all have done. Now, apart from the work that the Research Center has done already, and the Research Center has up to date about 80 different projects and solutions ranging from a wide range of things that we have researched on over the years. Actually, by the end of this year, we'll be closing in on about 100 different projects that we have worked on that touches this domain. And we want to make all of this available in one place. And this is why we physically have a lab, and why we also want to make all of this available to everybody, so that in one place we have one comprehensive portfolio of solutions that everybody can access and play around with and see what they can build with that. So already this project has been in the works for about 3-4 years. Already we have a lot of partners that have come to us and said they want to be part of this. So we have manufacturers, we have several brands, and we have actually a lot more partners behind these our traditional stakeholders in our supply chain who have already signed on. And what we've said is come visit and then make a call rather than sign up already. So we sort of stopped the sign-up process, which we will reopen now that we've opened up. More importantly, we've also signed up a couple of non-industry stakeholders, which we're very excited about. So the Swire group is Swire Coca-Cola, so they will be sending us all the uniforms. Swire also owns Cathay Pacific Airlines, so airline interiors and airline uniforms will also be processed and recycled and reused in this area. The Hong Kong Shanghai Hotel Group, the Peninsula Hotel, have been working with us on sustainable luxury for years now, so they'll be sending us all of their soft materials to be made into something new for them as well as other nonprofits and other research partners. Sometimes this works, sometimes this doesn't. Okay, so what we want to do is we want to make this a focal point for a lot of solutions. Physically, what does the Open Lab look like? It's actually a factory, and it's a factory where we have some of our solutions in work. So we have the scaling up of existing solutions. So let me share with you some of the things that we are using in this lab. And I want to share just enough so that you're all curious, so that you want to come visit. So for example, we have the high-tech part of the business. We have an AI system that we've been training for the last 2 years to identify post-consumer garments. Basically, what we've been doing is we've been throwing piles of clothes in front of a system and say, make a guess about what you see in front of you. And we've been using a series of cameras in a hyperspectrum environment. And so the system have been learning and making guesses about the materials, the color, the structure of how it's put together, and most importantly, the composition, which is how much percent of what material is in the garment. And what we have been finding is that we have been able to identify different garment types, and we have been able to identify it quite accurately, 90% accuracy, and we have been able to identify to date, I can put the next slide up, about 200 to 300 different compositions of materials. And the system right now is able to do all this in about 0.2 seconds per characteristic, over 90% accuracy. So that means the entire identification process of clothes moving down a conveyor belt can be done in less than 1 second. So we think that this will solve some of the bottlenecks as we deal with a lot of manual sortation and separation in post-consumer recycling. The green machine, something we talked about 2 years ago at ITMF, has now been scaled up, and we are now working on the second generation green machine. So we're very excited to have that in the lab. The second generation green machine will be discharge free, so zero discharge. It will also have a series of add-on solutions. Not only will it be more efficient, but the add-ons will include a system what we call AquaSweep. This is a system which uses sound wave we use sound wave in sewage water, and we are able to separate microplastics using sound wave without using filters. So no OpEx in the filtration process, and we're able to do this at scale, and currently we are able to achieve about 90% success with multiple sizes of microplastics. So the Green Machine 2.0 will also separate, but also decolor, and we will use the materials in a production line that we will have in the lab itself. And as you know, there's significant amount of outputs from the various things that we're making with the Green Machine, including fiber-to-fiber, without further processing, fiber-to-fiber reuse of synthetic materials, and a number of different uses for the cellulosic material. The most exciting of which is the super absorbent polymer, which we have been growing cotton in India. We're on a 4th crop of cotton in India that we are growing in an irrigation-free environment. And now we're also able to achieve cotton growing without the use of different types of other chemicals, fertilizers, for example. So I'm going to speed through the rest of this, just because. And also in the Future Lab, we also have a new technology that we've been using to grow cotton in a hydroponic environment. We've been able to grow cotton 4 times, improve the yield by about 400%, and we have been able to grow cotton in an artificial environment, and we're growing the most complicated and the difficult to grow varieties of cotton. These include things like Sea Island and other types of extra long staple cottons. And we have been growing it in a high CO2 environment, and the reason for that is we've been able to offset CO2 and to use it as a fertilizer. So think of this as an opportunity to grow cotton on demand and grow cotton next to where you produce and use cotton, and to offset the CO2 that we produce in the manufacturing and the logistics process of the manufacturing process, and by using the CO2 as fertilizer. So it started out as an idea that we tried to pitch. It is something that we have since then worked very hard last year to grow, and we have, this was the original site that was empty, and we have since then have had a lot of visitors to come visit us, and we have been able to install 80 to 90% of the machinery already, and we expect to be fully operational by November this year. A lot of the machinery you will find very familiar, because instead of using a lot of new specialized engineered machine, we have been using a lot of repurposed machinery that we found in the marketplace. So we are very excited, and this is a real factory. It needs to earn its own keep, and we'll start with about 3 to 4 tons of output a day, garment to yarn, and as well as feature some of the projects that we've talked about. The cotton growing area has become an Instagram success. So you see more and more people taking pictures of themselves in front of our cotton growing area. So all this to answer the question, why do we want to build a factory in the world's most expensive city in the world? And the solution, the answer that we said we want to give to people is that we want to create hyper-local solutions for all the post-industrial waste that we are generating in all the cities of the world. So if the world's most expensive city in the world can have a factory that can recycle all the waste that it produces, any city in the world should be able to do that. Thank you very much.
Thank you, all speakers, for so nice and brilliant presentations, and also for to be on time in each one. That is so important too. But I think it's the time for the people who are in the floor to ask to these brilliant speakers the question you have in mind. Please go ahead. Okay. There is one question there, please, to the right side of. Thank you.
Thank you, everybody, and congratulations. Oliver Shafat, Cybum Labs. I have a question for Samsara Eco. So I'm curious to learn about the stability and lifetime of your enzymes and how, at large scale, you plan on keeping it a continuous process. Because if it's batch process, then everything costs more and is not as sustainable, actually. So thank you.
Thank you so much for the question, Oliver. It's actually a really important one, and it's something that we think about all the time. In our process, we actually have the capability to immobilize the enzymes. Everything occurs in a continuous process as well. Because the enzymes are immobilized, it also allows us to reuse them for multiple cycles of the process, unlike alternative processes that consume the enzyme with each cycle in a batch type process usually. And so this really goes towards our economics and our scalability. Thank you.
And just to follow up on that, part of our enzyme design process factors in the stability of the enzymes themselves to maximize their lifetime in harsh industrial conditions.
I have a question for Edwin, please. In your view, what role can public-private partnership play in accelerating the transition to a more environmentally and friendly textile industry?
So the question is, what role can partnership play as we transition our industry? I think it's critical. I think that we have to work together to solve these problems, because I don't think any of us have the complete answer. I think also there is also, even though everybody is doing a lot of good work, I don't think there is one silver bullet solution that can solve all the challenges that we have as an industry. So I think it requires all of us to be open to a lot of experimentation and to take some risks. And I think the only way to do that is if we do that together. It is a pressing and it is a time-sensitive challenge, and only as we work together as a complete industry group will it be possible. Thank you.
Thank you so much. One, please, how does your CO2 PET fiber technology differ from or improve upon the 16 fibers approaches in the industry? I ask about how does your CO2 PET fiber technology differ from or improve
upon existing approaches in the industry. You can tell in yes. You can tell in China if you want, because there is translation. It's easier for you.
I think the filament of the factory is same the conventional polyester fibers. The structures and properties is similar.
Okay, thank you. Some more questions? Please.
Yeah, I saw the two different presentations about the cellulosic filament materials. Can you tell me the advantage of each raw materials? I think some of them is pulp and others are hemp. Would you tell us?
Yeah, maybe I take that. So I think on the one side you have a very nice project using hemp. Hemp is a crop that we can grow very easily. It's not very demanding in terms of what it needs as soil, has high yields. So it is definitely something the agricultural industry can focus to provide feedstock and raw materials for making fibers. Now we have a lot of sources of cellulose. That's what I wanted to say before. You have waste from agriculture. More than 80% of the waste from agriculture is getting burned today. And this is waste from the rice production, from the corn production, from ananas, fruit, coffee, whatever you want. This source of cellulose is 50 times bigger than we need to cover the entire needs of the textile industry. So it is an unvalorized waste, and HiQ has taken this approach to tap a large waste network. How can we create a technology that can go and use this waste and make high performance, high quality fibers out of the cellulosic waste? So I don't think that you can say that we differ. It's similar approaches. It's just that on one approach you grow hemp to make fibers, and our model on the feedstock side wants to take waste that is already available and is being burned today. So you have CO2 coming out of the combustion of the agricultural waste.
And maybe to add on this, in our case for the feedstock sourcing, we work with farming groups already growing hemp, and we take the byproduct. So we're really in an approach which aims to encourage more farmers to grow hemp in rotation with other crops so that it can benefit water, soil management, and so on, by bringing another added market to this byproduct of the plant.
Okay, I think we'll be finished now. Please beg you for a round of applause to all these speakers and for brilliant work they done in every field. Thank you very much, and with that, I think we finish for today, and I give the time for this presentation to Indonesian new conference. Thank you so much.
Okay, now we come to the last part of the conference, which is the invitation to next year's conference. I ask Michelle and Anne to the stage, and maybe until they are here, just a little information that there will be photos available on the download link, you know, where you found the conference program, where you found the presentations, the speakers info. There you will also find in the next few minutes or a few hours a lot of photos taken during the last 3 days that you can use at your discretion. With that, Michelle and Anne, where is she? Here. Oh, here she is. Okay, the floor is yours.
Good afternoon, everybody. My name is Michelle Cokrasaputro, an ITMF board member and also General Secretary of API, the Indonesian Textile Association. It is my honor to extend a warm invitation to all of you to join us at the ITMF Annual Conference 2025 and IAF Fashion Convention 2025, which will be held in Yogyakarta, Indonesia. Indonesia boasts a fully integrated textile industry spanning from fiber production, spinning, weaving, dyeing, printing, until garment manufacturing. Not only rich in natural resources, as the world's fourth most populous country with over 275 million people, Indonesia is home to a dynamic and youthful population, the average age being just 29 years old, with 50% of Indonesians between the age of 18 and 39. This not only positions Indonesia as a global player with the capacity to serve international markets, but also reflects the immense domestic consumption's power and growth potential. We are inviting you to Indonesia not only to experience the breathtaking beauty of our landscapes and the warmth of our people, but also to discover the vast opportunities that Indonesia's textile industry has to offer. We look forward to welcome you all to Yogyakarta, Indonesia next year.
So for those who doesn't know us, actually Michelle is my cousin. We are come from a legacy of our grandparents, batik. If you ever come to Indonesia, there is a brand name called Batik Keris. That's our grandfather. So like Michelle has said, as a IAF board, we are going to invite you, IAF and ITMF both. I'm IAF board, Michelle is ITMF. So we jointly would like to invite all of you to Yogyakarta, Indonesia, and believe us that it's not only about textile and garment, but we love all the culinary as well as all the traditional things that we have. And just for your information, finger crossed, this year and next year we will have more free trade agreement between Indonesia and the rest of the world, and therefore our competitive advantage are there. So welcome, please join us in Indonesia in October 24 and 25, 2025, and welcome to Indonesia with us being the host. Thank you so much. And now a slide video that as our associations and ITMF and IF has prepared for all of you here to showcase a bit of us. Thank you.
Indonesia, a land of timeless beauty, rich heritage, and a vibrant textile tradition that bridges ancient techniques with modern innovations. For centuries, Indonesia has been renowned for its exquisite textiles, from the intricate batik patterns to the vibrant colors of иккита. Our fabrics embody tradition and craftsmanship. These textiles, once treasured by royalty and traded along ancient routes, have left their mark on global cultures. Today, they continue to evolve, blending the spirit of our heritage with modern sustainability and renewable energy practices. Indonesia, an emerging market with a rapidly growing, productive age population, is home to over 3,500 textile companies, including 30 major manufacturers. We produce a vast range of textiles, from fibers and modern apparel to home textiles and industrial materials. Supported by a robust ecosystem, strong infrastructure, solid labor conditions, and a favorable investment climate, our industry has become a key player on the global stage. Next year, Yogyakarta, a city where tradition and modernity coexist, and home to iconic sites like Borobudur, will host the ITMF Annual Conference and IAF World Fashion Convention 2025. Join us for an inspiring experience where industry leaders will explore the future of textiles amidst the rich culture of Indonesia. Immerse yourself in the warmth and hospitality of Yogyakarta and discover the enduring legacy of our textiles. We look forward to welcoming you to the 2025 ITMF Annual Conference and IAF World Fashion Convention in Yogyakarta.
Now it's time to say goodbye, and before we leave you for lunch, we would like to say a few words of thanks and appreciation. The joint ITMF-IAF Conference 2024 here in Samarkand, Uzbekistan, is coming to a close.
And we would like to thank you all for having joined us in Samarkand, and we would like to thank our partners for having made this possible.
In particular, Mr. Davron Vatchabov, Chairman of the Chamber of Commerce and Industry of the Republic of Uzbekistan, and his very supportive team.
Mr. Mimukhin Sultanov, Chairman of UZTS, the Uzbekistan Textile and Garment Industry Association, and his wonderful team who have made the impossible possible across these days.
Then, of course, such an event would not be possible without having the support of the generous sponsors, diamond sponsors, Saber, Celal Textiles, DNZ.
Gold sponsors, Arise, Cotton USA, Groos Beckert, Indorama, Rieter, Saurer.
Silver sponsors, Benninger, Trütschler, and Uster. Thank you very much.
And our bronze sponsors, A&E, Cotton Brazil, Epic Group, the Global Organic Textile Standard, GOTS, Oerlikon, Rimtex, Tangiva, and Van de Wiele. And then we would also like to thank all of our speakers and moderators, which were the ITMF and IAF board members, for all of their insights.
A special thanks goes also to Chairman Zhang of Yangwon for inviting the spouses to a theater and restaurant. Thank you so much.
And of course, such an event would not be possible without the service providers. The AV team did a great job, the interpreters did a great job, and we had more than enough screens.
Also, the team that served us at the coffee breaks and the luncheons deserve a really big thank you.
And then last but not least, we would also like to thank our own teams at ITMF and IAF. Esther, Razieh, Roslyn, Olivia, who have done a great job behind the scenes.
We have been so generously received in this beautiful country, and we are sure that our hosts have left a great and lasting impression on all of us. Thank you once again.
And thank you all delegates. A big cheers to you, and hope to see all of you next year in Yogyakarta.
And now, enjoy the lunch and the company visits for those who go with us on the tour to see the companies in the afternoon. And else, we would like to wish everybody, of course, a safe journey home and a better business environment in the future. But most of all, we hope to see you all again next year in 2025. Thank you.
Reminder to all the award winners, please gather in front of the stage. We will have a picture, we will make the official pictures now. I invite all the award winners to come to the stage. We will start the official photo.
Congratulations. Okay, now Andreas.
Where is Andreas? Come on, Andreas.
Yes, thank you.
Yeah, no problem. Yes, yes.
Yeah, well, come in.
Yes, yes. Yeah, the cross.
Okay, here's
Yeah.
the lady.
We see you. Okay. Good. Okay.
Dennis, I think it's your turn, right? Gratulation, danke.
Hey, tennis. Okay.
Congratulations
Yeah,
once
tennis.
again.
Where's the tennis?
Yeah, the certificate, that's good. Thank you. Wonderful.
Yeah. You hold it. Yeah.
Yeah.
Okay. Yeah. Post sector. Okay.
Thank you.
Okay.
Well done, well done. Thank you so much. Thank you. Okay, Mr. Mai. Mr. Mai Feng. Oh, here he is. Please. Congratulations. Oliver brings it? Good. Please come here. We wait for the certificate. And we wait for the certificate also on the screen. That's right? Good, good. Yeah. Yeah, bigger team. The certificate is... Well, Olivier is getting the certificate. Just be a little patient. You will enjoy the lunch even more. You know.
Where's Olivier?
He's coming. He's on his way. Fresh from the press, right?
Okay.
So, hold it. Yeah.
Okay. Yeah.
That's good. Perfect. Thank you. Thank you. Thank you. Then Carlo. Here he comes. Great. Thank you so much.
Thank you.
Please. She's the one? Good? No. She tells us. Thank you.
Congratulations again.
Thank you. Thank you very much.
Herzlichen Glückwunsch. Danke. Okay, and now Vanessa and Matthew. Vanessa, congratulations.
Thank you very much.
Please in the middle. Please. Oops, what's wrong? Oh yeah, sorry. It's important. She will tell you how to hold it if it's good. A little up.
Great. Thank you. Thank you very much.
Well done once again.
Thank you.
Enjoy lunch now.
Thank you.
And now the two last one awards, Anne Ribou and Marc Vogt. Where are they? Here they are.
It's me.
The two of you? In the middle. She will tell you how to hold it.
Get close.
Yeah. It was a joke, huh?
Yeah, deliberately.
To make everybody Wait.
Wait.
No worries. Here we go. Okay.
Okay.
Ready?
Yeah. Hold.
We are ready.
Okay. Yeah.
Perfect. And last one. Nochmal. Felicitation. And last but not least, Professor Key, Edwin. I hope he's still around. Oh, here he is. Good. Perfect. Nochmal, herzlichen Glückwunsch.
Congratulations.
Congratulations. You go in the middle. Huh?
In the middle. Okay. Yeah.
Okay.
Thanks for having me. And let me come back.
Oh yeah, thank you. Sorry.
Yeah.
Move forward. Yeah, only the winners.
Oh, it's okay.
No, stay here. Now we ask Anne and Mark, please come back. We do a group photo for the international award with a neutral background, because that's one group of category for international awards. And then we ask the 4 winners, or the 3 winners of the Sustainability Innovation Award, and afterwards the group of the Startup Awards. Now the Sustainability and Innovation Award winners as a group, Carlo, Vanessa, Matthew, and Mr. Mai. Is Vanessa still here, and did they leave? Oh, I think they left. Oh. Yeah. Okay. Vanessa and Matthew, huh? They left. Okay. Well, we do it with those two. Maybe we do it. Okay. Thank you. And now the Startup Awards winners, I hope they are still around as a group. Oliver Schaffert, yes, perfect. Andreas. Dirk is here, and I think that's it, huh? And Madame.
Okay. Here we go. Good. Good. Wonderful.
Thank you, everyone, for your patience. Now enjoy lunch. Of what? And who? Yeah.